Alright, I'm going to walk you guys through this little PowerPoint that I have. It is on the website, but for some reason you go through it and you have some questions. Hopefully what I say now should help you figure out exactly what you're supposed to know. So on this first slide it just says, oh, this is all about forces. Okay. Now when you were in middle school or something like that, and you first were introduced to forces, it probably was introduced to you as a push or a pull, which is pretty much still exactly what we're going to consider it to be. However, there are lots of different types of forces that we're going to talk about. Another preconceived notion is that all forces create motion. Okay, and it's not true. If you look up there on the slide that I have up, it says sitting in your desk. I mean, if you just sit there, there are forces acting on you. You are being pulled towards the ground by the planet, yet you don't go anywhere because the desk you're sitting on isn't applying a force as well, and it's applying it in the opposite direction. Okay, if that chair wasn't there, then you'd obviously be sitting on the ground, and then if the ground wasn't there, you'd be moving towards the center of the planet, which would be pretty bad. Okay, so forces don't always have to cause things to move, and that's important to know. The next slide that's on here talks about our types of forces, and you'll notice that I've got it split into contact forces and non-contact forces. As far as non-contact forces, we're also leaving out electromagnetic force because we're just not at that point yet. But if you look up here in terms of contact forces, something called a normal force. Normal force being perpendicular to the surface. Now, I just wanted to clarify something. Normal is a math term for you, and what normal to the surface or perpendicular to the surface is, it's not referring to the surface of the planet. It could refer to the surface of the planet if it was standing on it, but if you were on a ramp or something like that, the surface of the ramp now becomes the surface that we measure the normal force perpendicular to. Now, I know it was kind of a mouthful right there, so I'm going to just draw you a picture of what the heck I'm talking about. If this was just, say, the Earth, okay, and you were sitting on that, and I'm going to draw you as a box, okay, then the normal force would always be drawn perpendicular, because if I extend this down, I would make a 90-degree angle with the Earth. The normal force is perpendicular. But let's say that we've got the Earth, and then there's a ramp of some sort, and you're on the ramp. Okay, your normal force is not straight up and down anymore. The normal force is off in this direction at some angle. Okay, because if I extend this down again, it would make a 90-degree angle with the surface that you're on. So just a little clarification there about normal force. Alright. A friction force. You guys have experienced friction. If you take your hands and slap them together and rub them together, you get some heat. Friction force is no different. One thing to keep in mind is that friction always opposes motion. Other things, applied forces is kind of a catch-all for things pushing and pulling. If you push a person or push a door or push a wall or anything like that, or pull something, that's all considered an applied force. Something else that will come up is a tension force. And it says it's caused by stretching. Usually when I think of a tension force, I think of a cable or a band. Something along those lines. If you think of suspension bridges, they use cables. Those are tension. There's tension in those cables. Those are the types of things that we can oftentimes label a tension force. Although keep in mind that for the most part, a tension force is a type of applied force. As far as non-contact forces, sometimes referred to as field forces, there's really one main one that we have to know for this particular unit, and that is the force due to gravity, or the force of gravity, however you really want to say it. You'll notice that so far every single one of these things has had an F with a subscript that pretty much explains it. So normal is an Fn, friction force is an Ff, applied force is Fa, tension force is Ft, and now the force due to gravity is Fg. Now, this is something that is hard for me to get over sometimes. People use weight and mass interchangeably, and they are not the same thing. If you look on here, F of g is the same as weight. Okay, weight has a relationship to mass where W equals m times g. So again, if I go back to this, if we were to make a graph of weight, which is measured, in the U.S. here in pounds. However, a pretty common way to measure it is in a Newton. Okay, because technically weight is a force. Okay, they're the same thing. Force gets measured in newtons, at least in what we're going to be doing in this unit. But if we were to make a graph of weight versus mass, and we did mass in kilograms, we'd end up with a nice straight line. And if that was the case, then weight would equal some number, which would be in newtons per kilogram, times the mass. Okay. Now, we haven't talked about this yet, but a newton is the same thing as a kilogram times meters per second squared. Therefore, if I look at a kilogram per meters per second squared and then divide it by kilograms, you end up with meters per second squared, or an acceleration. And the weight on this planet is dictated by your mass, and then the slope of that line would be a 9.8 meters per second squared, gravity. Hence, why the weight is equal to m times g. So weight and mass are not the same thing. They are directly related based on the value of gravity on the planet. Okay, so hopefully that makes some amount of sense. Okay. So anyways, on here I've got f of g is the same thing as weight. Weight is a force. And then mass, just to make sure you guys remember, it's the amount of matter that an object is made up of. Weight is the result of the amount of matter multiplied by the gravitational field force that is acting on it. So in this case, m times g. Alright, so that's a little bit of a start about forces. Hopefully it clears up anything that you might have questions on. Alright.